Hi student, in this video we're going to do a rather interesting problem. So what is this problem? Yes, we are asked to find the range of values for x for which 3x minus 5 over x squared minus 14x plus 49 is greater than 0 and x cannot take the value of 7. And you're asked to explain your answer. Right, so we're going to use Mr. Polya's 4 steps of problem solving skill to solve this rather challenging problem. So what is step number 1? So step number 1 is to understand the problem. Right, so one way of understanding the problem is to highlight the keywords. So what are the keywords presented here in this problem? Correct, the first one is x cannot take the value of 7. Right, so in your mind, when you see something like that, when you see x cannot take the value of 7, as a problem solver, you would ask yourself, why x cannot take the values of 7, right? Then the next thing is to understand what you are supposed to find. And here you're supposed to find the range of values of x. So what do you understand by this word range, by all the words range of values of x? So is it a fixed answer, or is it an answer in terms of inequality? And of course, last but not least, is the problem itself, is the inequality itself. All right, so let's go back to the range of values of x, right? So this, you will rationalize that your answer will be in the form x less than a, or x more than a, or it could be x more than a or less than b, where both a and b are real numbers, right? And what you're given is actually a fractional inequality. Right, and you have to keep this question in mind, that why is it x not equals to 7? So if you can answer all these questions, then you are on the right track to solving it. Alright, so let's start off by writing down some fractions that are more than 0. Right, so possible ones could be half, could be 2/3, could be 4/3, etc. So if I'm going to represent all these fractions, represent the numerator by the letter A and the denominator by the letter B, right, that we can see from the possible fractions given that both your A, the values for A and the values for B must be positive in order to get a value that's more than 0. Right, do you agree with me? Yes, I think you agree with me. Right, so the next question you need to ask yourself is that, can we have both A and B to be negative values too? Right, so to answer the question, maybe you can give yourself some examples. Probably instead of 2 over 3, how about negative 2 over negative 3? How about negative 4 over negative 3? Would you end up also getting a value more than 0? Right, yes, it's possible, right? So the conclusions that we can make here is, for A over B must be more than 0, the values for A and B must be both positive or both negative. Now, so let us now address the very interesting question is, why is it x cannot be 7? So if you look at it the other way around, right, we just let x to be 7 and let's see what happens. So if I'm going to substitute x equals to 7 into your fractions, right, and then if you use your calculator to evaluate the numerator and denominator, and you end up getting 16 over 0. You get the denominator to be 0. So what is the conclusion? 16 over 0. You can try using a calculator and evaluate 16 over 0. What do you get? Yes, you will get an error. So 16 over 0, it's not defined. It's not valid. Okay? Therefore, in these questions, it clearly states that x cannot be 7. Okay, let me repeat, because if you substitute x equals to 7 into your denominator, you end up getting a 0, and you have something divided by 0 that is undefined. Isn't it interesting? Right, so now let's come to step number 2. So what is step number 2? Right, step number 2 is to think of a plan. So we've understood that we have to find the range of values of x. So which concept involves finding range of values of x? Correct, we need the concept of solving inequalities. And if it's solving inequalities, then what are the concepts involving solving inequalities? So can you see it's actually a series of questioning. And for every question that you ask yourself, you try to answer it. Right, so the concepts of solving inequalities, we understand that when we multiply or divide both sides of an inequality with a negative number, we need to change the inequality sign. All right, I'm going to give an example. Clearly, 2 is more than 1. But if I'm going to multiply 2 and 1 with negative 1, then you will see that negative 2 is no longer greater than negative 1. It has become less than. Likewise, if I'm going to divide it with negative 1 on both sides, what happened? You end up getting negative 2 and negative 1. And of course, negative 2 is less than negative 1. Right, so these two are the basic concepts we have to remember regarding solving inequalities. And then the very important thing is look at the denominator. Usually the denominator is the one that giving us more problem. And the denominator happen to be a quadratic expression. So the next question you should be asking yourself is, what are some concepts you have learned managing quadratic expression? Yes, we have learned how to solve quadratic equation. We have learned how to factorize quadratic expression. So therefore, we can actually factorize the quadratic expression into its linear factors. Right, so to give an example, a quadratic expression x squared minus 3x plus 2, you can actually factorize it into x minus 2 multiplied with x minus 1. This is just one random example. Okay, there are many other examples you can try on. Right, so congratulations. We have achieved step 1 and step 2. Now we come to the step 3, which is actually the most interesting part, that is to carry out the plan. So you have the ideas already. How are we going to carry out the plan? Yes, we're going to factorize the denominator and we get x minus 7 multiplied with another x minus 7. Right, so you've forgotten how to do that. You can use the cross method. Right, so this will be one linear factor and this is a second linear factor. And if we stack them up together, you actually get bracket x minus 7 close bracket square. You actually get a fill in the blank. Start with the letter P and the letter S. Yes, you are right. We actually get a perfect square. All right, bracket x minus 7 close bracket square. It's a perfect square. All right. So what do you understand about perfect square? Yes, it's the value for a perfect square. It's always more than or equal than 0. But remember what we said earlier on in the questions. We say that x cannot be 7 because that will make the denominator 0. And we cannot allow that to happen. So if x cannot take the values of 7, then x minus 7 squared is strictly more than 0. So we can rewrite the fractional inequality as such. 3x minus 5 over bracket x minus 7 close bracket square more than 0. Alright, then let's go back to your step number 2, the concepts of inequality. If you multiply both sides with a positive answer, you don't have to flip the inequality sign, right? Right, so this is exactly what we're going to do. We're going to multiply both sides with bracket x minus 7 close bracket square, and then we end up getting just 3x minus 5 more than 0. Now we can do that. Remember, we can do that is because we have already proved that the denominator is a positive value. So this is something very important. We have proved that the denominator is a positive value, therefore we can multiply both sides of the inequality without having to flip the inequality sign. And then I end up getting x more than 5/3. But that's not the answer. Okay, that's not the answer. Complete answer will be x more than 5/3 and x cannot take the values of 7. Alright, so congratulations to all of us. We have achieved step 1, step 2, step 3. Now let's come at step 4, that is to look back. So what is the meaning of to look back? To look back means we got the answer ready, but are our answers valid? Is our answers reasonable? Right, so we got the answer, so let's check if our answer is valid. So since x is more than 5/3, we're going to choose some values that is more than 5/3 and some less than 5/3. And let's do some substitution. So the first value I'm going to use is x equals to 2, because 2 clearly it's more than 5/3. And if you were to substitute into the fractional inequality given, you will end up getting 1/25. And 1/25 is clearly more than 0. So x equals to 2 is a valid number to use. What happens if I choose something that is less than 5/3? Choose x equals -2. Yes, and you end up getting -11/49, which clearly is less than 0. So it goes to show that the values must be more than 5/3. You can try any other values more than 5/3, and if you see if you can end up getting a positive value. Hence, our answer is reasonable. Right, so we have achieved all the 4 steps of Mr. Polya's problem-solving skill. Alright, so we have done our investigation. Now is the time to write the report. Okay, so we're not going to write down all the little nitty-gritty of the investigations. We're going to write down the important things that we can summarize from our investigation. So this is how you can present your answer. Step number 1, understand the problem. So what are the key things that we can write it down? Yes, the answer will be in the form x less than a or x more than a, or it can be greater than a or less than b, where both a and b are real numbers, meaning your answer will be in the form of inequalities. We can conclude that values for a and b can be positive or can be both negative. And x cannot take the values of 7 because if we substitute x equals to 7, we'll get 16/0, which is undefined. So this is step number 1, understanding the problem. Right, so step number 2, think of a plan, right? So this is what you can write it down. We understand that we need to find the range of values of x, and hence we will need the concept of solving inequalities. We understand that when we multiply or divide both sides of an inequality with a negative number, we need to change the inequality sign. We can factorize the quadratic expressions. Right, so step number 3 is to carry out the plan. So we factorize the quadratic expressions. We end up getting a perfect square. So here we can eliminate that a, because earlier on, if you were to recall, that we mentioned that both A and B can be both negative, right? But here we have already found that the denominator is a positive number. And if the denominator is a positive number, the numerator must be positive. So here we need to add something here, that since the denominator is a positive value, the numerator must also be positive. Hence, A cannot be less than 0 and B cannot be less than 0. Alright, so we need to eliminate the second conditions that we've set for ourselves earlier on, right? Okay, so this is how you can write down the report for step number 3. Positive value, sorry. Let's add here value. Hence, A less than 0 and B less than 0 is not valid. Okay, right. Right, then of course, the last one is step 4, look back. So we can just use the same slide. Yeah, yeah, the same slide that I've used earlier on to explain, okay, to carry out the investigation. Okay, so I hope you have fun, right, using Polya's 4 steps of problem solving skill to tackle this question. Right, thank you.